you can lock down the behavior of an agent the way you used to lock down the behavior of any other container. But that agent is going to start circumventing your security policies in order to achieve its goals.
Hi, everyone. Welcome to the Built for Trust podcast. I am really just so psyched for this podcast. We're all about containers, and we're going to really talk about how fundamental containers are as almost like a stability point or a major building block within not only just AI infrastructure, but clearly around kind of cloud infrastructure, as well. And those two, how they are inextricably linked together. And so with that, I have the folks who really have developed container networking on the podcast. So actually, Thomas and Craig, I don't want to do injustice to your background. So let me ask you guys to say hi and just do a quick intro. Thomas, why don't you go first?
Sure. Hey, I'm Thomas. I'm the co-founder of Isovalent and our CTO of Cisco Security. Isovalent joined Cisco 2 years ago. Before that, we ran Isovalent for 8 years and developed Isovalent Cilium, the standard for container networking. And before that, I was a kernel developer at Red Hat for 10 years, doing low-level networking development. That's my background.
Awesome. Great. Thanks, Thomas. Welcome. So psyched to have you. Craig?
Hey, Craig Connors. I'm the CTO for Infrastructure and Security Group, which covers data center networking, compute, security at Cisco. I've been at Cisco for a little over 3 years. Most of my background prior to this in SD-WAN and SASE space at companies like Telari and Velopod. Nice to be here.
Awesome. Yeah, and those were great companies too, as well. So, Craig, thanks. Welcome. Really just so psyched to have both of you. So we're going to really kind of dive into this. I want to provide a little bit of context. I think this is really coming from within the ONU community to kind of frame our discussion. So we all know that enterprises are really kind of facing a large amount of uncertainty today because we have a token economy that we're all working within that really hasn't been budgeted for AI. There is now an AI FinOps kind of program within most corporations that are starting to emerge to try to manage that token economy. But an open question is this, is that these frontier model providers haven't really earned enterprise trust. And we clearly know that from the last couple of weeks as we've been seeing jailbreaks from, various different frontier models. So there's an earned enterprise trust, on security deficit that they are now really kind of working towards. But what's interesting too is that the cloud providers have that trust. And they built that trust over decades. It wasn't too long ago that we all were just saying, oh, we don't want to put our workloads into the clouds because it can't be trusted. And they worked hard on that to really build the trust for the enterprise marketplace. And they have. Now economics is starting to shift a little bit, and there's repatriation has been going on for some time. So there's this kind of movement kind of going back and forth around workloads. But the community within ONU voted at the last summit that really our future is all around hybrid. It's around hybrid AI infrastructure, both open and closed models. And the cloud providers play a big role within that. So the logical layer associated with that multi-cloud hybrid world, it lives within containers. And what makes container networking core to AI infrastructure is that movement towards hybrid. So I want to kind of give you that perspective, on the importance of containers, the importance of the ability to be able to network containers across multiple different trust domains in particular. So that's the context. Let's kind of dive into this, first. And so I thought it'd be good for us to lead maybe with Craig, before, we got into the technology, I want to really kind of have this original, what kind of motivated Cisco to acquire Isovalent a couple of years ago. So, Thomas built the technology. but Craig was instrumental in the acquisition. So, Craig, what did you see in Isovalent? That kind of drove you to kind of spearhead that acquisition.
Well, you kind of made the case for me already in your intro. So
Okay.
two big things that we saw happening. One, the shift towards hybrid cloud, and two, the fact that Kubernetes was becoming the substrate for AI networking made it imperative for Cisco as a major networking player to have a bigger foothold in the cloud and Kubernetes networking space. So that was one side. How do we extend this market leadership we have in enterprise on-prem networking to cloud and Kubernetes networking? But the other was the security angle, right? Isovalent built Tetragon. They were using eDPF for runtime security. And really, as Cisco's on this mission to merge security into the fabric of the network and converge networking and security and expand to cloud and Kubernetes, and Isovalent's there, they're the leader there, and they're doing converged security at the same time, it was a perfect fit.
Yeah. Awesome. Yeah. Well, in 2020 hindsight, it makes sense, but maybe, it took vision to do that. When was Isovalent acquired in 2024? Was that kind of around the time frame?
Yes.
Yeah. Yeah. So it took vision to kind of see that, and not to take anything away from that, but it took even more vision for Thomas for you to develop the technology, because you had to be doing this probably in 2020, 2021, time frame. So, maybe, kind of the question here is that what's kind of interesting, about Isovalent, is that most enterprises, are already running your technology. They didn't have to buy it. It was part of the platform, right? It came bundled within. It was almost like the early days of Intel inside. When you basically went, K8, you also, got, Isovalent, and you got, the core, I think, technology that came with it was Cilium. And that's essentially the default plumbing for most, if not all, Kubernetes deployments. So maybe, if you can kind of talk a little bit about in particular Cilium, and I think, is it Tetragon, as well as the core kind of networking components and technologies there.
Sure, yeah. So it was, I think, around 2016 when we got started. It was around when a company called Docker introduced containers for the first time. Right? And at the time, we were working on virtualization. So I was working on OpenVSwitch, which was kind of the de facto network virtualization platform or open source project. It was developed by a company called Nicira that got acquired by VMware. This became the VMware NSX-T in the end. When containers came around, it was becoming clear that the level of networking that we had been developing to that point would not actually fit containers, even though the initial wave of solutions that hit the market were all repurposed, like network virtualization solutions repurposed for containers. And we really saw the need for scale, but also identity-based security as the core pillar that we had to base this on. We had this amazing technology called eBPF laying around, which was kind of a different companies used it for different purposes. It was ideal for software-defined networking, but we also saw that it was ideal for application profiling and monitoring and network and runtime security. So it's a super, super powerful technology where you could actually see fit for multiple solutions. We ended up building Cilium first, which is the container networking interface, originally built for Docker. Then Google brought Kubernetes onto the market, and that quickly became the standard for container orchestration. And that was the opportunity for us to really tailor to Kubernetes and step by step become the standard. And I think initially it was a dozen of users, a couple of hundred of users, and then eventually the first cloud provider in the form of Google adopted us and baked Cilium straight into their Google Kubernetes engine. And voila, when you created a managed Kubernetes cluster, you had Cilium under the hood automatically. AWS followed, eventually Microsoft Azure with AKS, Azure Kubernetes Service followed. And step by step, we kind of got baked into the Kubernetes distributions one by one, which was ideal for us as a company because our technology was already embedded in kind of the default Kubernetes distributions. And all we have to do as a company is to convince our customers that the enterprise distribution that we have that adds a bit of more value on top of the open source version is definitely worth it. And that's how we turned this into a successful business model as well. So started with Cilium on the networking side, and eventually we evolved this into Tetragon, which is the runtime security component. We always saw that from a security perspective, you need both. You need the runtime, the process context, and you want the network context as well. And for true security, you need to eventually combine the two together, and that's what we're doing at Cisco now.
Yeah, that's great. So great. So obviously Selenium, kind of networking of containers, and Tetra. Oh my God, I forgot the lines. Yeah, I kind of went through a kind of a mind block there for a second. Security. So actually, what's really kind of fascinating, is that there's a couple of things that you mentioned there. One is those days back around Nicira, with Martin Casada, and there was the whole focus around kind of open flow and kind of software-defined networking, focused on the data center, but it was focused in the wrong place. It was focused around these white boxes that really never, took off, or took a long, long time, for them to actually start to get a little bit of traction, which they're getting now with Sonic. But it said you guys really, you really honed in and focused on containers. It's so funny. I remember the first time when Docker came into the vernacular within the industry. I was having this conversation with someone, and they were like, "Oh, you mean the people who make pants?" I'm like, "No, I'm not." That's a different kind of Docker, But I think there was a whole flurry of activity that was going on there, that I think was mostly in the domain of the hyperscalers, and then it really started to branch out into all parts of enterprise compute. So really insightful for you guys, to be in that space at that time. And to be kind of integrated, as kind of that default kind of networking in the container world, led by really the hyperscaler companies.
I was actually a super funny anecdote here, because you mentioned Martin Casada. Martin was our first investor. So it was he later said this was the easiest investment decision ever, because you guys are completing the vision that I started. I really had this vision and this thought a little bit too early. For containers, this makes even more sense. So for him, I think it took minutes to convince him, and he wrote our Series A check.
Yeah, that's a great backstory. I remember I was invited, Martin and Steve Mulaney, who was running the Nicira at the time, invited me to come in and to kind of just give me an overview about what they were doing. And the only thing they talked about was OpenFlow at that time. There's, and I'm not sure if it was mostly kind of a, kind of an open version to VXLAN is kind of open, open switch, kind of a open switch, I forget is it kind of, maybe it's just open vSwitch or something like that.
Open vSwitch was the project. Yeah.
Yeah. Right. But I thought I'm not sure if it was just okay, it's almost a lot of times, when you're kind of in that early stage, a lot of companies will kind of talk about something over here to distract you from what they're really doing over here. And I'm not sure if that was it, or if there really was kind of a belief in OpenFlow and, in the company. But clearly they did really, really well with the acquisition of Nicira by VMware. And I think that really kind of helped establish, Martin, as a major figure within our industry. So anyway, where my mind was kind of going as you were talking, Thomas, is that one of the disruptions that Kubernetes or containers did was with CMDB, right? And so when the world was physical, we could really have stability around what is the database around all of the devices within an infrastructure? Now that's like nearly impossible, with kind of containers coming up and going down and, and just that level of dynamicism. Is there anything that you're kind of working on to kind of help, kind of close that gap so that you can't do this with people? That's got to really be kind of an AI dimension, to kind of keep track of, the state of an infrastructure at any one particular point in time. But you guys have got to be at the center of that.
Yeah, absolutely. I think that actually goes back to like the fundamental design consideration of Cilium, and we haven't even invented it. I think we kind of looked at Cisco ACI, which did it before us, and just kind of to decouple the networking and the security concept. And very similar to like if you look at something like SSL or TLS, that does not depend on how your network plumbing is being done. And while for, let's say, for virtual machines, but I think in kind of for the virtualization age, it was still possible to look at like network topology and also use network topology as a way to do segmentation and things like that. For the age of containers, or if we look now at AI agents, that's impossible. These things are volatile, they come and go. You really need to look at the connectivity layer, and then on top of that, completely decouple to security, identity-based. So by not depending on network addressing to understand who somebody is, do and enforce network security. And that was conceptually what we introduced with Cilium, which matched exactly what Kubernetes designed or how Kubernetes saw the networking as well. And it's actually the same way as Cisco ACI is doing this as well.
Yeah. Awesome. Okay. Yeah. So we had that separation. And then what would feed? Is the concept of CMDB outdated then?
I think it's no longer kind of the CMDB may not see everything anymore, right? It may have a partial picture. You may have a partial CMDB in the cloud, like or different CSP. Kubernetes is kind of a mini CMDB. For some customers, VMware is still part of the CMDB as well. We now need to compose this together from multiple sources, right? And over that CMDB, build an identity layer, or we can do security, and also for observability, use that identity layer to identify who are you talking with. And what's interesting is it's no longer just workloads. It has to span to the endpoint. And then on endpoints, on your laptops, you will on agents, they will also need identities. They will need non-human identities. So it really, I think that the traditional sense of a CMDB needs to be reshaped, right? Because it's just too static of a concept.
But that was the core value of CMDB, right? So is CMDB dead as a concept? No, it's more important than ever. But the way we implement CMDBs has to be this AI augmented data layer. It has to be completely different.
Yeah, I totally agree with that. It's, the world was a lot easier before, but we have a lot more flexibility now, and we definitely need a new approach, for both kind of physical and kind of virtual, worlds to understand state at any one particular point in time. The identity piece, I never really kind of like associated the identity part of what you all have built, with that. But clearly, I see it as a component of agent identity, and that is key and fundamental towards the agentic world that we're all moving into right now. So maybe we can kind of circle back to that. But I think what I wanted to do is make all of this real, because like it's almost like maybe not the best analogy, but it's like when you're kind of like, when you're studying math, you kind of do algebra, and you don't really understand algebra until you do calculus. You don't understand calculus until you do differential equations. And you have all this level of kind of virtualization, that happens. And so, and I think this has a little bit of that. And so I think as you go higher in the virtualization piece of it, really good use cases come into focus. So, and it kind of really explains everything that's going on underneath. And so I think if we talk about OpenAI, that might help, people kind of understand, because that's OpenAI, kind of like runs, on Isovalent, and containers. So why don't we talk a little bit about that about OpenAI as a use case, a real good concrete use case.
Yeah, OpenAI is, I think, fascinating. We have, I think lots of fascinating customer reference stories that we can talk about. OpenAI is super interesting because it combines multiple aspects, I think, that are really interesting for, I would say, core networking people. There's scale. These learning clusters are massive. Like, these are massive Kubernetes clusters that data engineers are using to build models. And then there's also OpenAI applied, where they run agent farms. So if you run OpenAI Codex in the cloud, actually your task runs on a Kubernetes cluster. AI infrastructure has put entirely new levels of networking demands on servers. Like, we're talking 400, 800 gig server links to the switches. These are like performance numbers that for traditional software networking were not approachable before. So it kind of shows that eBPF, or the use of eBPF by Cilium, really allows us to be high performant as well. And the last factor is, these are kind of even more extreme than containers. It is as volatile, but these are long-running batch jobs as well. Like, these learning jobs, they run for days. And guess what? If they get interrupted and you have to restart, it's insanely costly. So the reliability angle is probably telco level +2, something like that. So I think it actually combines multiple levels of data center requirements: scale, high throughput, performance, reliability, and then also modern security. I think we've been very challenged by some of the demands and some of the questions that came up. Well, in a learning cluster, you need access to various data sources because you pull in data from here, and these data engineers, they just want to pull data from somewhere to pull into the models. At the same time, you want to prevent that the model can get stolen. So you're in this position where you don't have a static kind of connectivity demands. It's very, very on demand. At the same time, you want to protect the models as they get developed. So we had to come up with completely new network security models that allowed us to lock down model theft. So that was interesting. It was a very challenging, I would say, onboarding, but it was super interesting and really brought the product and technology forward.
Yeah, I bet. The level of scale and dynamism that you're seeing in there has got to be kind of unparalleled. What a great proving ground for scale. Just amazing. Craig, do you want to add anything to like the OpenAI, use case or any other use case?
I think Thomas has covered it. It all ties back to the intro, right? What did OpenAI need? They needed the ability to run across multiple different environments. I think the one thing Thomas didn't mention is what happens if you need to extend more compute and you're the company buying all the compute in the world. Well, you need the flexibility to adopt any type of substrate at any time. And so I think that's the one other thing I would call out, that like it not only gave them the flexibility to do this in a high performance way with security, but also across whatever infrastructure essentially they could find.
Yeah, that's actually a really good point. Just the kind of interoperability or the mobility, of containers kind of affords that, flexibility around compute. And you have consistency around networking, you have consistency around security. Yeah, that's good. Great point. Let's dive a little bit into then kind of agents. And I'd like to maybe give you an example that I think most in the ONU community are struggling with. And you might already have a lot of data, on this. And it's basically this, is that I think as we kind of move into an agentic kind of world, what most, and most haven't, they haven't kind of have this, large scale deployment of agents where you have an agent that is given a task with an intent, it now has rights and access that are granted to it. It has a persona associated with it. It has an identity associated with it. And then maybe it accesses an MCP a server for access to various different tools, could access, data, kind of a data repo to help in that task. It may realize, hey, I don't have all of the skills in order to do this task. So I'm going to go to an agentic directory and find an agent that actually could help in this. it pawns or distributes part of a task there, and then all of a sudden you get this distribution of traffic flows in order to survive and to deliver on that original task. With that basically, and we hear that mostly from like the hyperscalers who are kind of dealing with this stuff like in scale. But what I think in the large enterprise, they don't understand is, what does this do to bandwidth requirements? What does it do to latency requirements? What are the traffic patterns that are about to emerge? How does it work, and does it work on existing enterprise infrastructure? So are we looking at, in essence, like peering into a world where, we're going to need kind of a wholesale upgrade around the infrastructure that we built? And maybe we contain this right now to the data centers because the wide area is a totally different, beast, in this as well. So, maybe kind of building upon all your expertise and all these different use cases, are enterprise networks ready for this kind of traffic flow?
I mean, traditional enterprise security is not, that's for sure. I think the most challenging thing, and this was hammered home this week with the OpenAI and Anthropic jailbreaks, is that you can lock down the behavior of an agent the way you used to lock down the behavior of any other container. But that agent is going to start circumventing your security policies in order to achieve its goal. So if it needs to access the internet to achieve its goal, it will change its IP, it will change its protocol, it will spoof a port, it will do things that are never before seen, right? So I used to say agents behave like humans because they were unpredictable, but now it's more than that. It's like humans that have the intent to circumvent your security, with the best intentions of accomplishing a task.
Yeah, and the skills that are beyond like so many, to understand the infrastructure, probe an infrastructure, and then find exits, that maybe others couldn't find. Yeah.
Well, I think there's so many different angles. So just like if you look at the connectivity itself, a traditional data center may not even have the bandwidth with the rise in east-west communication that we'll see from agentic workflows. Then you typically lack the visibility. I think the first thing you ever need if you have agentic workflows is to be able to identify and discover agents, because you may not even know that you have them. So you need to be able to identify them. Then you need a way to cut them off, because as Craig is saying, they may be doing all sorts of things, not intentionally bad, but maybe like an 8-year-old trying to find creative ways around rules. So I think even those basics are not always found in traditional build-outs. I think definitely time to look at network infrastructure, level up. Some may actually come with, I would say, modern agent platforms. If you look at something like NVIDIA OpenShell, that is based on Kubernetes. So it's a Kubernetes platform, and that has some capabilities in. And because it is Kubernetes based, again, we can bring in Isovalent, and we get quite a bit of the capabilities that we have built to lock down agents, to get visibility, to, for example, grant tokens to agents without actually giving it to the agent itself. It's very interesting. It's not a new use case to us. One of our customers, Palantir, had this a while ago. They are running lots of batch jobs of untrusted workloads. So they got from their customers, they get workloads that they run, and they need to address services. And because these were untrusted workloads, they did not want to give them the credentials directly. So we've built essentially what is called TLS origination, which means that the workload can access the service, but from the outside, we inject the certificate required to access this. So you can grant the workload access, but you're not giving the token, the SSL certificate to the workload itself. And that's exactly what we need for agents as well, even on a new level. But that same concept is needed. We want to grant access without giving the actual credentials to the agent, because the agent will abuse them if we do so.
Yeah. So I think what I'm hearing clearly on the security side, there is a wholesale upgrade, refresh, new approach around security infrastructure that's needed. And on the network infrastructure, The physical plumbing may be there, and upgrading that, obviously you're upgrading, switches, and moving, depending upon your requirements. There are plenty of options around increasing the bandwidth and, the 2-tier architecture that we've built in the data centers should be able to scale, because those are not even should, they will be able to scale. That's what, all of the hyperscalers use, and also all of the kind of frontier models use as a kind of a 2-tier class, non-blocking matrix, to connect, servers and switches together. So I think we're there. That could be scaled up, and we've kind of proved that can be scaled up to hundreds of thousands of GPUs. But it's really kind of the virtual networking, piece that needs to be kind of thought through carefully to start thinking about agents and agents at scale. Does that kind of capture it? Kind of networking is more on the virtual side of it. Security is almost like a total rethink.
I think many network services that were previously maybe in hardware are moving more to the virtualization side, because it's often hard. Like, say, we can take firewalling as an example. Like scaling the plumbing itself, doable, right? We know how to do that. Scaling a centralized firewall and trying to apply to all east-west traffic, that's becoming very hard, very expensive. So we're seeing definitely more distributed models of services, firewalling, load balancing, visibility. And one way to do that is through software, right? To actually use either server capacity or a DPU on the server or a DPU on the switch.
Makes sense. Okay. All right, great. So I think, all right, so everyone get ready, if you're an operations, person, you're a CISO, CTO, it's time to really kind of start thinking about your story to the board for, refresh, and increasing, expenditure in your infrastructure to support the AI era that we're all in. But let's kind of guide that a little bit. And I think probably the two most important, topics, around, this scaling out. And I think, Craig, you talked about it around security, and that's really identity, and security, and how those are becoming kind of converge together. So I think the previous discussion that we just had, really everything up to this point, is that we know that all the CISOs within our community are asking, what is that agent? What is it allowed to touch? Who assigns it a persona? What are the rights that it is granted? How are those rights assured? How do we monitor what that agent is doing? How do we make sure it doesn't go rogue, within our environment? So there's an awful lot of discussion and concern around agents and their identity, and how do we put in the right controls and the right guardrails to govern this agentic world that we're all in. So, Thomas, maybe if we can start with how identity is built into the fabric. I think you already started talking about that, but maybe if we can kind of isolate that around identity, and then, Craig, if you can kind of take that up a notch, around, Cisco and you and Tom Gillis have done just really a fabulous job around kind of reinventing security within the Cisco product set. And so when we talk a little bit about the Cisco security strategy, after Thomas talks about how identity is kind of baked within the fabric.
Yes, I think we really see identity, and overall security should be a property of networking in general. And in order to achieve that, identity is a core pillar. And for containers, that's non-negotiable. Containers come and go. And in particular with containers, we often see that multiple instances of a container implement a service. So you can scale up the number of containers to have more capacity to deliver a particular service, right? Which is different from, let's say, a traditional database where you need to put a bigger box. With containers, you can simply scale up the number of containers and you get more processing power. But that also means, from a security perspective, you don't want to then constantly change your policy Like if a new container comes up, you don't want to change the policy. So you bind policy to identity, and an identity describes all the replicas, all the instances of a container. So that's baked into our understanding. And we're doing this very similar to how Cisco ACI is doing this as well, which means the network packet carries on the network level a tag that describes the identity. So we're not looking at the IP address to figure out who this is coming from. We're looking at a tag. So that's kind of the baseline. And then we also have more modern ways of carrying this identity and doing enforcement all the way to TLS, a mutual authentication, which would be, in modern container worlds, is the ultimate form of zero trust networking, where you're not just doing identity-based, but you're actually doing TLS with cryptographically signed identities and certificates that you can mutually authenticate sender and receiver. That's kind of the end form of this. But typically, this is kind of a journey from identity description of policy to network tag-based identity to then the last step being full TLS-enabled authentication.
Yeah. Is there like, does kind of like quantum cryptography play a role in here?
Absolutely. Absolutely. Yeah. I mean, I think traditionally, maybe 5-10 years ago, FIPS was the primary kind of complication around encryption and authentication. Now, I think post-quantum safe ciphers are kind of a must. So that is obviously what we're building in as well.
Yeah. Yeah. Especially with the recent, executive orders that were signed and actually what the prelude to that was kind of a scare within the intelligence community that really just kind of drove a lot of activity in quantum. And now quantum is, I know, for example, in our fall program, we have a dedicated track, just around, how to get ready, for quantum. So that's great. You guys are already baking this in, because now it's like, containers are fundamental, to the world that we're living in. So, Craig, Cisco broader security strategy.
Yeah. So Thomas and I said something that might have seemed disconnected. So I want to pull it all back together to explain the story, because I talk about fusing security in the fabric of the network, and Thomas mentioned decoupling networking to security.
Yeah,
but I thought they're at odds, but they actually mean the same thing in a weird way. So obviously, our strategy has been to fuse security into the fabric of the network. Why? Because everything touches the network. No matter what an agent is doing, it's not doing anything without crossing the network somewhere, right? And it provides a uniform point for us to apply enforcement and get observations. Mm-hmm. The shortcoming is that the network's not enough. Right? Thomas mentioned identity. We talked about agent behaviors. That's things like semantic inspection of prompts and stuff like that. All of that is contextual metadata on top of what we had from the network. So the question is, how do I build a network that is uniform in providing me observation points, uniform in providing me enforcement points, but isn't the only thing involved in doing that observation and enforcement? And that's the two pieces that we have managed to put together by bringing the Cisco security portfolio on top of networking. So now, when I've got agents, they're not only running in the data center in a trusted environment. We're going to have agents everywhere in the world. Yeah. So if I can build common visibility across wireless, campus switching, data center switching, firewalling, my Kubernetes runtime environment, if I can use all of those places as potential places to proxy traffic to an MCP gateway or an 8A protocol gateway, if I can use all of those places as places to insert enforcement, now I have turned my network into a living, breathing security fabric. And that's really the vision of Cisco security. And that's why Isovalent and Cisco made such perfect sense. And you already see this in like the Nexus and Isovalent coming together with Hypershield as the bridge. You see this in practice, how well this works. Now I have my Kubernetes environment, my switches, and these firewalls running inside the switches, doing layer 4 to layer 7 security consistently across the infrastructure.
Yeah. Yeah. It's, it was interesting, when you were kind of describing just outside of the data center too. But I think that's within a trust domain. But I think also, like, your architecture also scales across multiple trust domains, right? Because we'll have agents in kind of in the frontier models, we'll have agents within the cloud providers. And I think, like Cisco's kind of security solution is, the way I kind of view it, correct me if I'm wrong, is that it's both a multi-agent, multi-trust domain kind of architecture, to provide both secure, agent creation and destruction, monitoring across these various different domains. Correct?
Yep. And whether it's, how do I detect an agent that's talking to an on-prem model? Cisco is always there in the path to inspect that and secure it. If an agent's using an API to talk to a frontier model, again, Cisco's always in the path to inspect that and secure it. So having that ubiquitous footprint is really what allows us to deliver that.
Yeah. Okay. I think this is kind of like, maybe just kind of the last point. When we were doing the prep for the podcast, Thomas kind of mentioned something that I've actually been thinking about, and he basically, what you said, Thomas, was that like, that I would be surprised about how many people are now kind of like pulling workloads back into the data center from cloud because of AI. So it's kind of AI is pulling workloads back, into the data center. So even kind of cloud first, enterprises are, either expanding their data centers or building new data centers again. So can you go into a little bit on that? Because I think what that to me says is that we're not just talking about AI workloads here. We're talking about all kinds of workloads that are now being hosted in containers that are portable and mobile. And AI is suited for that because most agents are just going to be in a container. All right. So I guess the bottom line is that, make that make sense. Why is AI pulling that in?
So I think it's two factors. One factor is that I think it used to be hard to run containers in your own premises and not in the cloud. That's no longer true. There are plenty of simple ways to run containers in your data center that you do not need public cloud for this. And the second aspect is AI and agentic workflows. And essentially the majority of applications will become agentic in the future. So the change of AI in terms of how much data it will force onto the network, I think will make public cloud, or is already making public cloud, I think a level more expensive that we have not seen before. And even before AI, we have seen large users that were in the cloud move back because of cost reasons. And AI is accelerating that. So definitely we're seeing container is no longer a barrier, and AI is driving workloads back into a data center.
Okay, well, mission accomplished. You made it make sense. Good job. All right, excellent. Well, I think that's probably a good place to stop, because I think what it really hits on is that we're kind of in this uncertain phase around building hybrid infrastructure. Part is, in a public domain, and part is within, a private domain, your own data center. And we don't quite know where the weights are going to shift. They will shift over time based upon economics and new technologies that come into the marketplace, new kinds of workloads and applications that get created. But I think for infrastructure professionals, what is fundamental and what is important is that you design and architect infrastructure that enables you to put your corporation in the best possible position to be able to move when the market moves, or when technologies move, or when the economics shift, so that your corporation can be competitive within its particular respective market. And I think hopefully what we did in this podcast is show how Kubernetes and also the Isovalent, is fundamental to that new infrastructure that we're all building, and how it supports both existing workloads, as we've been doing for the last decade, and also how now AI workloads, especially agentic, are building upon that really through that kind of building block around containers. So I think that's all we got. Any final words, Thomas or Craig?
Oh, it's been amazing. Thanks for giving us this opportunity. I know Craig and I will love to talk about security, and I think in terms of Kubernetes, we're just getting started. I feel like couple of years ago, it felt like we have been peaking. But if I now look into kind of enterprises and customers, many of them are just learning about Kubernetes, whether it is for containers or now for agentic farms. I think we'll have a lot more fun with customers around Kubernetes in the future.
Awesome. Yeah. Craig, any last words?
Yeah, thanks for having me. I'm excited about the things we can't talk about yet, as in addition to the things that we are talking about. So a lot more to come in the future on this.
Awesome. Great. Thomas, Craig, thanks so much. And everybody out there, thank you so much for plugging in. Take care, everyone.